Okay, hi everyone. This is our third lesson on straight line graphs, and we're going to make life a little bit more difficult today, but we're not going to do so much theory. So we're going to do two sections of theory, two new things, and then I'm going to set you off on quite a few different tasks so that you can begin to consolidate all the different things that you've done over the last few lessons. Right, so let's get on with this section. So this first section today is the opposite of what we did at the end of last lesson. So we are taking a graph that has been drawn for us, and we are trying to come up with the equation ourselves. So we've got the graph, we want the equation. At the end of last lesson we did the opposite, so we had the equation and we drew the graph, and we're actually going to use most of the same skills that we learned at the end of the last lesson, namely what is the gradient and what is the y-intercept. If I can work out what the gradient is and if I can work out what the y-intercept is, then I am fine. So let's have a look at the first one. As before, the easiest thing to spot is the intercept. The y-intercept is -1 on that one. And now I'm going to look at the gradient. So what I want to do is I want to see for every one that it goes across, how much does it go up? In this case, it goes up by 2. So I think that we've got a gradient there of 2. So I think the equation is going to look like this. It's going to have a gradient of 2, and it's going to have a y-intercept of -1. And it's that quick and easy. If you can find out what the gradient is, if you can find out what the y-intercept is, then you are fine. On this one, we've got a gradient of 1 for every one that it goes across. It goes up by 1. And we've got a y-intercept of -5. Now, obviously I don't want to leave it like that, so I'm just going to get rid of the 1. And that's done. And on the last one, I can see it's pointing down, so it's going to have a negative gradient. I can also see that it's got a y-intercept of 2. So I've got y equals, and it's definitely going to have a +2 on the end. What about the gradient? Well, for every one that you go across, you go down by 2. So I think that means it's got a gradient of -2. There we go. So what we're doing there is we're taking the graph, we're looking for the y-intercept and we're looking for the gradient, and then we're going to put the gradient in front of the x and we're going to put the y-intercept at the end where they live, and that's it. So if you wanted to pause the video now and you can have a go at the exercise that matches those examples, and then you can come back for the second and last section in a moment. Okay, welcome back. So this is the last bit we're going to do. We've got some more difficult gradients going on here, and I've been avoiding talking about these the whole way through, which has been quite hard actually to find questions that avoid these types of things. Now you'll notice that these graphs are all quite a bit flatter than the ones we've been working on previously. So the gradients before were quite a lot steeper. The gradients we've been working on have been looking like that, or been looking like that, or been looking like that. So we've got a much flatter graph. This one's even flatter than this one. And this is obviously negative and quite flat. And the reason that they are flat is because they have a fraction for the gradient. So let's have a look at why that is. So on this graph here, it gets quite difficult to spot when they're fractions. But if I do the small little triangle like that, for every one that go across, I think it's going up by 1/2, but it's really hard to spot. So what you're going to need to do is you're going to need to use a bigger triangle to try and spot that relationship. So bigger triangle, maybe that's a nice big triangle like that. So I've got 3 there and I've got 6 there, which is looking much more useful in terms of finding out what the gradient is. And you might remember this formula that we mentioned last lesson, or maybe even the lesson before. Gradient is equal to rise divided by run. So the rise in this case is 3 and the run in this case is 6. So I think therefore we've got a gradient in this first example of 1/2, and that matches my initial idea where it's across 1 and up 1/2, but it was very hard to spot with a small triangle. Let's have a look at this one. On the face of it, it looks the same, but it's not quite the same. So what we're going to do is we're going to use another big triangle. I'm going to draw across, and then this is 2 and 6. So we've got rise of 2 and a run of 6. So I think we've got a gradient in this case of 1/3. So that's smaller than a half. And then lastly, this one. This is the most difficult one we've done. It is both negative and it's a fraction. And I know that because it's pointing down and it's quite flat. So I'm going to do the same thing. I'm going to find some points that I think it goes through. Here they are. So that's 2 and 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Right, okay, so the gradient is going to be the rise, which is 2, divided by the run, which is 7, and it's also going to be minus because it's pointing down. So there we have it. The gradient in that last graph is -2/7, which is really, really difficult. What about if they asked us for the whole actual equation rather than just the gradient? Well, actually, the rest of it's really easy. So I'm going to go back through these 3 examples, and I'm going to find out what the full equation is as well. So in the first case, it's obviously y equals a half of x because that's the gradient. So I'm still just putting it in front of the x. And what's the y-intercept? Well, on this first one, the y-intercept was 1, so that's really easy. In second graph, we know already that the gradient is 1/3, so I'm just going to put that right in front of the x. And I think looking up at the graph, it's got a y-intercept of 2. And then finally, obviously the most difficult one by a long way, is y equals, right, we've got -2/7, and then we've got a intercept of 3. And then we're done.